current light sources of intensity ratio and are implied in the concept ratio of intensity is the maximum minimum if the interference pattern is in the interference pattern is the two current sources of light, the intensity ratio or N1 and N2. The intensity ratios N1 are the intensity ratio is given is I1 by I2 is given that is equals to 10. So question is talking about the intensity of maximum and minimum. Like, you know, maxima and minimum. The question is talking about the intensity ratio of maxima and minimum here. So you can do directly this one question as well. See what is maximum A1 plus A2, A1 plus A2, and what is minimum A1 minus A2, A1 minus A2. You can say root I1 plus root I2 whole square divided by root I1 minus root I2 whole square. This is maximum and this is minimum. So here you can say I1 by 2. So all this is ratio is given. All, uh, so take basically this is like I2 I1. Suppose I2 I1 is and so I2 is or basically and I1 and I naught. So if you put here the root I naught plus n I naught root n I naught will come. So I'm writing this here directly n I naught plus root I naught divided by n I naught n I naught minus root I naught whole square. You take I naught common everywhere, so you will get this option. It's very good questions. You have to be and know the concept of how to solve the questions, and you can easily solve this question. Very easy, doable, but you have to be aware about it that how to take the ratio. This question interprets the pattern of n with the two current light sources of intensity ratio. Beta in the interprets the ratio of I max plus I max minus I min by I max plus I min. What is I max? So intensity ratio is given. So I basically I is for beta times of I naught. So I max, if we talk about I max and I min divided by I max plus I min. This is what root I naught. So I'm putting that here value. It will come something like this root beta I naught plus root I whole square minus root of beta of I naught minus I naught whole square. And on the same way, it will come plus here. If we expand it, so see what we get like y1, y2 beta sin max with sin. So if you solve it, automatically it will come. mm, Later will come like this format of your minus 4 root I1 I2 root I1 I2 and divided by denominator will come in this format 2 I1 I2 I1 plus I2 I1 plus I2. So if you want, you can keep this okay in your brain. Otherwise, you can just solve it. You will get this relation. And afterwards, what you can do, just divide by root I1 right, and root I2 in denominator. So you will get to this format. You will get this format. Here you have to check it. This is plus I max and this is plus of I min. Plus of I min. So, plus of I min. Here it will be plus. Here it will be plus. Yeah, so this will come in the form of question saying I1 by 2 is given. There is the beta 1 by beta. Solve it, you will get this. It's very good question, but this question is advanced level question that you, if you are clear about the concept, you can solve the questions. This is the distance between the two slates in the movement is A and the distance between the opposite slate B. B is a point resting directly one of the slate. So basically, two slate and B is a point directly in front of one of the slate. The part difference between the waves having and deep from the two paths is basically what is the if this distance is 20. So from here you say range width is what? Range width you can get directly from here. This will be d over 2. So basically beta range width is given directly. Range width is given directly. Is with all lambda d by d. Range width is lambda d by d. And from here, and you know, question talking about one part difference is what that for d y by d, d y by d. So if you can write this in this format, you can write just from here that you can solve it. So what d is d obviously, d is d and d y is d by 2, and if this is given b, if you solve it, you get d square divided by 2b, so d square divided by 2b. It's very good question, advanced level question, but it's asked. Okay. So you have to know how to solve this question. So it's very good question, very good question, very good question, very good question, very good question. To do this question easily, instead of implementing the addition between the slate is P and the slate is in from slate the maximum rate of the found opposite to slate from the speed, the order of that band is okay. A young council implement okay question talking about in the order of that band is basically for maximum maximum y equal to, so you can say if you want what is beta for maximum, this is n lambda by d, n lambda d by d. This is for the maximum. This is for the maximum. The person should be also in the corner of that band is okay. So here it, it is both basic. So what is this? Basically path difference is this is the path difference. This is the path difference. Yes, so this is the path difference. So you should find out S2P square minus S1P square. So you will get this one S1 S2. So what is S2P square? So basically traditionally not this is small d between the slits d, this is capital D. So from here you can find out capital D square minus D square and this is if you put this value as 1p, so what is s1p? That is capital D. From here you can get what you can get s2p minus s1p, s2p minus s1p, that is what path difference. This is what path difference. Basically, this is what path difference is. Okay. Now you can put all the values one by one. You can put all the values one by one. So you will get this value. See, you take a d common, take a d common. If you take a d common, so you will get this product. And then you know path difference. And so here you are, if you solve it, you will get this by 2d. Then this is what? And this will be the factor of n lambda. This will be the factor of n lambda. Path difference will be the factor of n lambda for maximum. So n lambda will just multiply by 2 numerator and denominator, and from here you can find out the value of n. This is a very good question, advanced level question, but your concept of clarity should be very strong. Then only you can solve this question. Yeah. In this question, we have accidents of the wavelength of light is this centimeter and that of the blue light is this centimeter. Then this is red light and blue light. The value of n for which n plus 1 is blue bright event constantly and it's red event. Value of n for which blue bright event constantly and it's red event. Question is talking about NF right event, okay, NF right event, okay, coincides with NF right event. Can you think like this that n plus one, the question is talking n plus one, okay, n one plus one, right event of this and NF right event of this will coincide. So both limits will be equal. So both limits will be equal. So if this condition applies, you can directly solve n1 lambda 1 equal to n2 lambda 2 n1 lambda 1 equal to n2 lambda 2. So the red light is given 7.5 into 10 to the power minus 5. Similarly, and 7.5 into 10 to the power minus 5. And this blue is given blue given n plus 1, n plus 1 5 into 10 to the power minus 5. Okay, you can find out the n. This is again very, very famous questions, and this question comes, so you have to know how to solve and how to deal with this. You can take approximately answer. In observation experiment, the lambda is 5 and the distance between slits is 0.2 and distance between slits and central maximum. The distance for maximum from central maximum. Beta is over 3 lambda d by d. You put the value, you will get the answer. So it's very easy questions, and you can do this question easily. It's not like that. Yeah, but you have to be aware how to the questions. Okay, so you have to know this. What is here path difference? Is this what is 3 lambda? This is path difference. This is path difference. It's not from here. This is actually beta. You don't need to worry about it. So once you solve, you can get the value. So value will be like this, and option number 4 is correct. Very good questions. You have to aware about the concepts. That's it. Like, we can all that you see that in 50 to lambda d by d, then at some transparently display place. In place of a lambda now we can give by the 4 d and d by d. And this is given that if the term is often then transparently display 150 and 7 price is often in the same range. Now here you can see out everybody, everybody. Large. Solve it. So you what you see says 5 lambda. This is 5 lambda, 5 lambda, 5 lambda, and divided by 7 into mu minus 1 equal to t. So question is talking, okay. So basically question is talking about the thickness of the from what we are getting is that if that okay, this is dark green. See, this is dark green. It will be I'm writing directly and that in place of 5, 8, place of right and then writing directly you can solve it. But right it okay, so that's the thing for the field of supervision. Uh, uh, yeah, yes, yes. 5, 6, and here it's in 4. I think I read that if the target is direction along direction C and if the path of direction is not mentioned. Yeah, so from here, if you see mu minus 1 into t, so mu minus 1 into t is what this. So here direction not mentioned, that's why we are getting different answer. So see, if we are not getting answer, so we can switch our of the conditions that are known to it. You can go one side plus or minus, so basically you can take minus of 7, minus of this one, okay, minus of 7 lambda and minus of take it like this, okay, minus of 7 lambda and a plus of 4.5 lambda. Do it like this. Okay. For me, what it become minus is 1.4.5, 2.5 lambda of this. So you can find out from here, you can find out the relations and you can solve it. In this questions, in Young's experiment, two green light of wavelength 500 nanometer is used. Okay, so what we are using in Young's experiment, we are using blue-green light. Blue-green light. The slits are 1.2 meter, 1.20 meter apart, and the viewing screen 5.40 meter away from the slits. Slits are 1.20 apart, and hinges with this. This is very easy. What I am doing. Okay, see. So it's our one. So D small d is given that is 1.20 and the screen capital D is given that is 5.40 and global light is to be able lambda is given so you can directly find out range material lambda of D by D. You can put it and you can solve it from here directly. A source emitting wavelength or negative noise instead of the separation between the slits in this and the interference of the 1.5 meter away from the slits. Mm, so it's wavelength. This is used in young surface in terms of the 1.5 meter away from the slits, and this is the linear separation between the first maximum of the wavelengths. First maximum of two wavelengths is so basically what you can say. You can take okay, this and lambda d lambda one d by d minus of n lambda two d by d. So basically here n is what one. Basically for both first maximum you are talking about, so there it basically solve it. You can directly solve it also directly lambda d delta of lambda divided by d by d. So here you will get the value. It's very good questions, very good questions. Okay, so these questions okay usually comes and most people don't want to do this question. Okay. You can do this question. Yeah. This is also experiment the distance between the slate is 2 millimeter and the fringes are often at a distance of 10 centimeter from the slates. Here, the distance between the slate is 2 millimeter. So a capital D is given that is distance between the slits. So I think the distance between the slits is 2 millimeter. D small d fringes are often at a distance 10 centimeter from the slits. So capital D is given 10 centimeter. On a transparent plate of 0.5 meter placed in front of the one slit is found at the interface partnerships by the So it's basically just to do the refractive index of the material of the plate is so it's shifting is given. Shifting is given when transfer things in front of one slit found at the interface pattern sections. Okay. So basically it's shifting will be what by mu minus one into t. Mu minus one into t. Yes, ma'am. So mu minus one into mm, t. So shifting is already given. So from here, if you put the values, you can get it directly in also it. So from here you can see if you put all the values, you can get the values, and from here shifting. So basically in terms of pattern, you use this relation always. So basically shifting is what mu minus one input it and capital D divided by D. So you put it, you will get the values. It's very easy and very questions you can do it. Two current sources are placed open apart from the fringes observed from 1 meter away. And two current sources are placed, two current sources are placed 0.9 meter apart. The small d is 0.9 millimeter and the fringes are observed 1 meter away. So capital D is what 1 meter away. The wavelength of monochrome light used in produces the subjects dark fringe at a distance of 10 meters from the center annually. The question is talking about okay, wavelength of monochromatic second wavelength of monochromatic light used and the wavelength of monochromatic light used if it produces the second dark fringe at a distance of the 10 meters from the fence. The question talking about given you the distance okay from the central and distance of the second dark fringe you have given, so you can put the values you can get the answer. So you can see the calculation will come like this. So the second dark fringe that is basically this is what 1.5 lambda d by d. Solve it will become second now. Second, yeah, 1.5 lambda d by d, and this is y. And so from here, you can put the values, all information given in the question, so solve the values and you will get the answers. In this question, a beam of light consisting of two separate wavelengths, 65,000 angstroms and 5200 angstroms, are used to obtain interference for engineering experiments of limit extend the least distance from the center of maximum of the bright fringes are due to both the wavelengths coincide with least distance from the center maximum where the bright fringes due to both the wavelengths are one side will be. So basically, it's an easy question. So you can do it. Okay, it's using interface. Basically, N1 6500 into 6500 equal to N2 into 5200. You can check by and like this N1 equal to 1, 2 like this. And then you can find out from here. You will constitute two wavelengths. This is the use of interest so this is the least distance from the central maximum where the bright fringes due to both the wavelength will coincide. From here, you can easily solve it. So So here you can keep in this thing in mind that the bright fringe for both the wavelengths will coincide for n plus one fringe n plus one fringe, and you can solve it like or even you can solve it like the n1 and n2. From here you can also find out the values. No issue. If you put into values, the value will come like this n equal to 4. So distance from you person talking about distance from central maximum, you can use this relation for information given. So you beta is what y and this is what lambda 1 d and divided by d. So from here, I can do this question you know, should it, yeah. From sodium light of wavelength 59 and extend the interpreted indices of order and extraordinaries are the refractive indices. This is what are the path difference between the two rays emerging from the plate of thickness. You can see what is the phase difference between them. So question is what are the path difference okay, between the two rays emerging from. Okay, so this person talking about what are the path difference between the two rays. So the also the light wavelength is refractive indices between the extraordinaries are this and this. The refractive indices given respectively for person talking about path difference. When it comes to plating, what is the phase difference between the person talking about phase difference as well. So see here from here, if you see film of the industry mathematical pattern, mu is equivalent path of mu t. Okay, so basically here, so if the refractive index is given path difference between mu of t and in place of mu of t, here two refractive index you will take equivalent refractive index that is mu naught minus of mu e into of t. See here, I'm showing you this the refractive index corresponding ordinary extraordinary or this respectively. So basically, if you take the difference, and so what are the path difference between the two rays? Path difference between the two rays, running from the so this will mu two minus. So basically, what mu into t, mu one into t minus of mu two into t like this also will be one minus of mu two into of t. So from here also you can think. So from here, what you are getting is that okay, this these if you put all the values, it will come in this chemistry. Question is talking about. mm, mm, So this is what basically if you check it, this is lambda by 4. If you put lambda is given in the question, if you put lambda divided by 4, you will get this is no, this 0.472.4 angstrom. This is lambda by 4. So from here you can find out the value. This is a question talking about phase difference. Phase difference is from here you can find out the phase difference. Delta phi phase difference what here 2 pi by lambda into delta x, 2 pi by lambda into delta x. So from here you can solve it. 5 by lambda into delta x is given lambda by 4. From here, lambda cancel out. So this will be equal to 2 and 2. So this is what 5 by 2. This person being of light is incident in the normally pastel C. The intensity of emergent light is I know it is incident on the terminal pastel C2. It is called no light emergent from C2. Now C is emergent from 45 degree towards C2. Initial light emergent from C2. Okay, yeah. Basically, unpolarized light is given I1, I2 by 2 cos square of 45 degree conductive rotate. So I naught by 2 and cos square 45 is 1 by 2. So this is what I naught by 4. So now the question is saying you this. So, uh, okay, beam multiplied light is like intensity will be like I in inside of the intensity of the light emerging from C2. Now C1 is rotated through C45 is intensity of the light emerging from C2 is the light is like this. Okay. So see here, we are using terminal crystal. See, okay, no problem, no problem, no problem. Found it all like emergent see which rotated. So you can go with either. You can think it is. Okay, so if you use a polarization, you can go like this. To change it, it's here. So next questions we have. Is there three or more number of polarities and three or more, three or more number of polarities and capital just kept in the path of the underlying light of intensity. I said that the angle between two successive polarities other than the negativity, then the intensity of visual light two or more number of polarities and kept in the path of different light and so that angle between any two successive polarities is other than the intensity of the emergence, which should be what less than I. It cannot be more than I. It cannot be zero more because it's three or more number of polarities means n number of polarities you are putting here. Okay, you are putting here n number of polarities. If you put it, it will come less than I. Yeah, this option is given you to confuse, and no need to worry about it. Don't get confused. You can solve it easily if you use the concept after you solve it. So sunlight is reflected from a calm lens, and the reflected light is 100% polarized. At a certain extent, sunlight is reflected from a calm lake, and reflected light is 100% polarized at a certain extent. The angle between the sunlight and the surface of the lake is sunlight is reflected from a calm lake, and the reflected light is 100% polarized at a certain. Okay, so this is lake, and this is lake, and sunlight is coming, and 100% of it is polarized. Polarized. So basically, it's okay for stress angles theta b so the angle between the light sunlight surface can not respond to the reflective index of the water, not even should given. So actually this will be the angle because tan theta is equal to tan theta p or tan theta p you can say equal to mu. So from here theta p will be equal to tan inverse of mu. So it will be tan inverse of 4 by 3. So you will get this angle. It's a very good question because all it is yeah, it's just okay, what the angular rate percent of reflected light in that is something that angle between sunlight and light is um, okay, question see here what the angle between sunlight and the surface. Okay, sunlight. Okay, this angle basically this angle is with what this angle is with Brewster's angle. Question is talking about this angle, so you will subtract from the ranges. So this is go with these options. Okay, so very good question. See, you have to be careful what question is asking, otherwise you do mistakes. Okay.